Hello everybody, today I'm going to explain the solution to the third problem from the 2025 USACO February contest in the bronze division, the problem named printing sequences. In this problem, Betsy is learning to code using a simple programming language, and we have here a bunch of definitions and executions. So as you can see, this kind of programming language is reminiscent of maybe a very simple program. In your favorite programming languages, you can think of like ref and something as like a for loop, and the print statements obviously as print statements. And in this code, for example, we are printing 1, 2, 2, 3 times, as you see. And now we have a bunch of inputs for which we need to check whether they can be created using a code like this one, but with at most k print statements. And obviously k is from 1 to 3. And in this problem, we are given the samples, and we know for each of them how many print statements we need to perform, and to make sure that when we get this thing done, we also have to be careful about making sure that we don't overcount the number of print statements and so on. Now, how do we even think of a problem like that to begin with? And at first, when I read the problem, I saw a very important detail. The number of integers we have to print, as well as the number of print statements we are allowed to perform, is something that gives us the motivation that we might be able to use some sort of a brute force. Because this sort of brute force approach would probably help us with solving the problem, and given that n is up to 100, even if we have something like n cube would still be good enough, because we have to also deal with 100 such inputs. And because we are allowed to have quite a slow code, we can think at very simple rules that make us let's say get to the answer more easily. And what would some of these rules be? Because we now want to see a way to get to compute this answer to compute this sort of sequence with as few print statements as possible. Now, as you see here, if we look at any part of code which is completely surrounded by a for loop, I will call it a for loop from now on when I mean a repetitive statement. When we see a for loop, this sort of for loop will have the same code, but will have the same print statements, but written a few times. It can be 1, 2, 3, whatever. And this gives us the motivation for a sequence of print statements to check whether we have any sort of a periodicity. Because if we have any sort of periodicity, then we can reduce the problem to finding out how many times we have to write a print statement in order to print the smaller sequence. Because then in order to print the bigger sequence, as you see, even with this sequence, it's the smaller one printed 3 times. So again, we want to be able to do that. But now the question is, what if we have a code that consists of multiple sequences? Like, for example, we see it with this code as well. And now, in order to check this, we have to also take in account that we can have the print statements also end at some point, and also the for loops. And this gives us the motivation that if we have a code which can be reduced to a bunch of simple print statements, then we can have a for loop which deals with the first part of the code, and then a for loop which deals with, let's say, the second part of the for loop, with the second part of the code. So in a way, let me formalize a bit some of these things I mentioned so far. So let's say that we have to solve the problem for the subarray left to right. And we now have two cases. Either it's periodic, and in order to check if it's periodic, then we have to go through divisors of the length, so right minus left plus 1, and check if they look the same. And all of these sequences look the same, then we can just repeat it like we saw in the example with that kind of sequence. Now, obviously, there might be certain strings or certain sequences of numbers we print, which would lead to even higher numbers, or would lead to even higher periods, or even lower, depending on what we have. But this is not the only case I mentioned, because we can also have a case where we can't quite do it with just a for loop, but we might have to split the process in two parts. So we can choose some x and have the answer for the sequence between left and right as being equal to the answer between left and x plus the answer between x plus 1 and the right end. Why would we do that? Basically, it can happen that if you don't if you can't simplify it using just one for loop, then you might have to split it in two for loops, not nested, but two separate for loops, which might have in turn their own nestings and so on. And now, in order to compute each of these sequences, we can rely on recursion to get from the bigger one to all of the smaller ones. But very importantly, we want and we must make sure that we never compute the same sequence more than once. And in order to do that, there are many ways we can think about it, but the easiest and the closest to the bronze syllabus is to do it recursively, which I'm going to show in a moment. And basically, I have here a recursive function which takes as parameters the left and the right end of the interval, as well as the list with all of the answers. And obviously, if the length of the sequence is 1, we can do it with a single print statement. If we already computed the answer, there is no point in doing it again. Then here we check for the period. We check whether there is any sort of period. Because this is very small, we don't even have to think of like divisor optimizations. And for a given divisor, we need to check if the period actually is consistent across the entire range. And if so, we just update the answer with the potential answer for the smaller interval. And then here we fix the split point, because we might not be able to perform this with a single for loop. And then we just return the answer for the current interval. And all we have to do after this is to check whether between 1 and n we needed at most k print statements. And now, because k is so small, I believe that there will probably also be solutions which rely on various degrees of casework, maybe something which checks with two nested for loops where to split, or maybe even check if there are some smaller periods somewhere. So this is not the only approach, I assume. And even I have another approach for this one as well, for those of you who are more experienced with pre-computing stuff and may have also seen some more advanced techniques. There is also an iterative solution, which I don't think belongs to the bronze syllabus, but it's worth presenting, where all I did was to implement the same solution, but iteratively. And when I implemented this solution, I computed the answers for the subarrays in increasing order of their length. And I kept the same logic. Whenever length is 1, the answer is 1. we check for the periods, and then we also check for the split points, and again the same logic applies. But then again, I would say that the recursive solution is much easier to understand, and given how small the inputs are, I believe that it's the most practical solution by far, if that makes sense. If you enjoyed watching this video, please like the video, subscribe to the channel, and press the bell button in order to be notified every time I post a video or any other sort of solution to any competitive programming problem. In addition, as I make more videos, I would love to hear your suggestions and feedback in terms of the content I make such so that I improve my content in the future as well, be it for the other USACO contest as well as for any other competitive programming competition I cover. Last but not least, if you or someone else you know is interested in improving their USACO results and want to work more closely with me, you can check out my website in the description where you can find details on how to join my tutoring program. As a new addition, I also have a new project where I'm planning to add as many USACO solutions as possible to the past problems, and you can have a look there and again see my work as I add the solutions for the various divisions, thing which I'm planning to finish very soon. Until the next time, good luck for the remaining contests in this season as well as for the future contests, and see you next time. Cheers.